when Bedford Dave came over a couple of weeks ago, one of the sets he left for repair, because we did that Midland 3001 while he waited, was the Audioline 342 remote. So it's one of these where everything's on a handset, and I mean, that's well worn, isn't it? So one of the things we will need to address is there's no fuse holder on the power lead, so I am required to sort that out. What he seemed to say was there was no LED display on it, and this has a 20 core cable running between the handset and the main unit. If there's anything wrong with that cable, this radio is a write-off. That is not repairable. And I've got one myself that way, and it's actually the screen that's broken of all connections in mine. So I've got the trader service sheet. Those of you who've been in the UK television trade and audio trade will recognise trader service sheets as being a jolly good thing, a bit like the Sam's Photo Fax in America. And they started in 1932, and they ended about not far after this in 1983. I think they went up probably to 84, and sometimes there were multiple parts. And the electrical and electronic trader, which was originally the wireless trader, it was a weekly trade magazine, and this came as a free supplement when you subscribed to it. And with me having a shop at the time, we had trader. We also had ERT, electrical and radio trading, and they were jolly good as well. So they did one or two of their sheets for CBs. The low TX40 was one, the Midland 2001 was another. And I just and that big Midland base station 76900. So I think I ran to 5 parts. So we do have the information, and if you didn't have LED on this thing, and I hope I haven't researched this and it isn't the fault, the LED is driven from this IC, which receives serial data up the connector. If any of you have seen the realistic 2003, which is their one-hander, it didn't use this kind of technology. It just had 8 wires which ran up the cable. But this and the Binatone breakerphone used the LC7181 encoder decoder for serial data and the 7191 in the handset to do the display. So you've got it's multiplexing the display up one wire and then decoding it at this end. So if you've got no power to this IC, you won't have any LED. So I wouldn't like to think of how much an LC7191 chip costs to replace, but I'm going to open this up because I would think we're going to have to. I don't know which side opens, so we'll probably end up with both. I probably see one of these every 3 years. And it's a really good connector, you know, it's almost industrial. I've opened the right side, luckily. So, straight away we can't see anything dodgy in there, apart from a bit of a bent case. There's no bulging capacitors or anything like that. So we won't put the fuse holder on because we're running on the power supply, which is current limited. I won't bother connecting an aerial up because we're going to need to actually sort this problem out, or just not bother. So we've got the power on, and as he says, there is no LED display. Actually, I will just put the aerial connector in just for a second, just loosely, just see if there's any transmit. There's no transmit. I'm going to put channel 20 on my signal generator. We'll just see if there's any receive, because we may be getting some clues from this. If there was no transmit and no receive either, we may have the 8-volt rail down. But I'd hate to have to open up the handset. So we don't know which channel 20 is. It's there, isn't it? That's channel 20. So it's receiving. That's 0.3 of a microvolt. It's receiving well. I'll switch channel lock on. It's got no transmit low power, no transmit high power. So it's looking at that common denominator where there's no transmit and there's no channel display decoder. So we know the synthesizer is running. So we know that the LC7181 scan generator and data encoder is working. Otherwise we wouldn't be able to select the channel. We know the synthesizer is working, the LC7137. There's another wonderful Sanyo chip. We know it's a Uniden made set. We know that as well. So there's a lot of it working, but it could still be a total white elephant if we can't get to the bottom of it. So I'm going to have a look at the circuit diagram. We'll see if there's anything common between transmit and the power that goes to the data decoder for that display. And we'll just pause the video while I look at that. I'm going to put some experience into this instead of just some fault finding. This could actually save us an awful lot of time. Now, any of you who have worked on the Audioline and the Uniden Uniace will know that the 220 microfarad capacitors have all just about died, and if they haven't died now, they're going to die next week or tomorrow. And I've just had a look on the circuit diagram, and if this transistor 18 has got a short circuit output, we're not going to have any transmit rail. And capacitor 107 is on the output there, and capacitor 107 is 220 microfarads. See what I'm getting at? So let's see where that is on the. Now what you do on these 107 is in A2, so A2 is where? A2 107. Let's get that the right way round. It's that one there. So if that was short circuit, and that transistor's warmer than I'd expect, let's turn the power off. And you know what I'm going to do? There's a 220 microfarad there. Change that one. We'll change both those capacitors, because that is what I think's faulty, and if that isn't faulty now, it will be next week. So having taken those out, the way that Uniden mark the board is once the capacitor's missing, you've got a white dot. That's the positive. So remember, your capacitor is marked with the negative. So the capacitors we've taken out there, they mark the negative, not the positive, but the board is marking the positive. So while we're still on record, and I don't know which one is which, because I really don't care, I've taken both of them out. And let's test this one. Okay, that's reading high, which is usually indicative of it failing. But not actually dead. And that's lost half its capacitance at 101. So that one's also not right. So they certainly want changing, and they're getting it. Okay, so going back now onto this, having changed those two capacitors, we now have transmit. And if we put picture in picture on, we can see it's doing about 3 watts. So that's sorted one fault out. So going back into record, we're now going to look at the handset. I've just taken the lid off that. There's the LC7191 decoder chip. And what we need to just do is look at the circuit diagram. And I think it's either pin 1, 2 or 5. If my memory serves, there's a good choice there, isn't there? If my memory serves me right as to what we need to be looking at. Just look at those first. Pin 1, nothing. Pin 2, nothing. 3, 4, pin 5, nothing. Just check we're not barking up the wrong tree. No, we've got power there. So we'll look at the circuit diagram. Pin 1 we should have 6.4 volts on. Pin 2 we should have 6.4 volts on. No, it wasn't pin 5. It's pin 5. Oh yeah. Pin 5 of the cable is the transmit line back from the main unit for the tally light. That's all pin 5 does, put the tally light on. So we haven't got power coming in on, I think 2's the actual, I haven't got a data sheet for the 7191. So we should have 6.4 volts coming in from pin 15. But what colour wire is that? You know. It doesn't kindly tell you. So once again we'll just prove it. Pin 1, nothing. Pin 2, nothing. And back to the circuit diagram. Is there anything in there that could drag it down? Well, we've got capacitor 602 could drag it down, which is 0.01, so that's unlikely to have failed. 601 could drag it down. 0.068, that's unlikely to have failed. So there's nothing in there. The only electrolytic capacitor is on the transmit receive line, and that's now working. So it's got to be the fact there's no power coming up to pin 15. So put that down. While I've got that mic in bits, we'll run it through the dishwasher, I think, even though it's a customer's. How do you find pin 15 when it's not marked? I think we have to look into the circuit diagram and find where it comes from. So, pin 15 goes to diode 15 and is all part of this regulator circuit here. So we would have a Zener diode there. If that was short circuit, we would have no power on that rail. Of course, if the lead was down on pin 15, we'd also have no display. So that's another reason. I'm just going to trace that back once again. And also 15, 10, 11, 12 are linked together. It's easy to find. I'll switch off. It's actually easy to find that Zener diode, I think. Look at diode 15. So if we look that up, diode 15 is in location A1. A1. So give a diode 15. Is right next to the LC7137. So put the power back on. So it's the diode just there. So just to put that on there, just put that there. So diode 15 has got 6.1 volts coming out of it. So chances are that anything that's 6.1 volts on this connector, I mean, it shows you the pattern of the pins, but it's not. Basically, it's the center 3 that don't go anywhere. See, the trouble is, where there's the connector, there's bits of print coming away, so it really needs to be treated with kid gloves. I'm going to tell the customer never to unplug that, because the strain that's on that is clearly phenomenal, and I can see that it's quite possible that that's where the problem lies. There could be a cracked track. We might have to put a little wire link from one side to the other when we know. There's 6.1. So we'll just look in the handset. To be honest, we need to take this out because we're going to have to clean those pesky controls, which are really dreadful. Hopefully we can do something better than how it is at the moment, but we're not going to promise anything. I've got a sneaking suspicion we've got to take these knobs off. So all that exercise has proved is it's the blue wire. So whilst we've got this in bits, I'm going to take a break have lunch and take the opportunity to put some of these microphone components through the dishwasher, even though it's not mine to do, because what's that sticking out? It's in a bit of a state.